Hello everyone, welcome to my video. My name is Arnanda Prabaswara and I would like to present my IBM Capstone project about classification of acute lymphoblastic leukemia using machine learning models. Let's get started. Acute lymphoblastic leukemia is one of blood cancer type which can attack on children below 5 years old and adults over 50 years old. This kind of cancer needs serious treatment. So in this project, my use case is to classify the cancer cells and healthy cell and then build machine learning model with high accuracy and high reliability to that get to that can classify the cancer cell and healthy cell of acute lymphoblastic leukemia disease. So in this project, step by step, what I need to do is first data quality assessment, then exploratory data analysis, then data visualization. Fourth is feature engineering. Then we do model training, and the last we evaluate the model. The dataset that I use is from Dr. Sarjito Hospital in my city in Indonesia. It's not an open source dataset. The dataset consists of multi-class labels from mature and immature white blood cell. Our focus is to classify the cancer cell, which is lymphoblast cell, and put the other cells as healthy cell. That I call it as non-lymphoblast cell. Lymphoblast is the immature form of lymphocyte cell, which is one of mature white blood cell. In this dataset, I I have no in this dataset have no missing values, but the class is imbalanced that we but the class is imbalanced, and also I extract the image data to various kind of feature that consists of area, circumference, solidity, granularity, circularity, average RGB, contrast, entropy, energy, homogeneity, fractal eccentricity, core area divided by cytoplasm area, core circumference divided by cytoplasm circumference. And each area to homogeneity, we extract the feature in core and cytoplasm. Then we do exploratory data analysis. First, I want to know the correlation between the feature, and in this heat map, we can see that the brighter the color means more positive the correlation, and the darker the color means more negative the correlation. We can see that some of features have positive correlation to the labels, but a lot of features have negative correlation to the labels. For detailed correlation, we can see at this chart that we can know features that have a lot negative correlation and few of them have positive correlation with the labels. So we need to do feature engineering to deal with it. Next, before we do feature engineering, we need to know visualization from distribution of the data. First, we want to know distribution of the class. This data consists of multi-class label, but our focus is just classify the lymphoblast or the cancer cell with and the healthy cell, the other cells. So we convert the data into binary class, non-lymphoblast and lymphoblast cell, and we can also see that the class is imbalanced. And we do also visualize the distribution of each feature. We can see at this that each label has similarity distribution to another, but there are some features that give significant difference, like average RGB or others that have positive correlation to the label. So this is the distribution of the feature that we can see. Energy cytoplasma have positive correlation, have different distribution in each label, like entropy cytoplasm. So what we need to do in feature engineering, first I do feature selection, then standardization the data, and then oversampling the data. First, for feature selection, I use backward elimination method with p-value threshold is 5%. Set it as 5%. Then next we fit it to the model with all possible predictor or independent variables. And then we identify the predictor with the highest p-value. Is the highest p-value greater than the significance level? So we remove the predictor. If no, we use the features. Then after we do feature selection, the number of features is reduced to 20 from 30 features. That we can see in this page that the feature have been selected to next to be processed. And then we do standardization data. Standardization of the data is needed to make the distribution of the data is not wide and boost the algorithm to train. We can see from the left box plot that data have wide range of value, so we do standardization. The data is now so the data is now near to 0, that we can see in the right box plot. And third, we do oversampling the data, that we can see that the class is imbalanced. We use smooth method to balancing the class, and we can see that the balancing class in the right chart. Next, for model performance indicator, we use to evaluation metric that is accuracy, which is the right prediction divided by total of dataset, and F1 score, which is represent of precision and recall. Then the machine learning algorithm that I use in this project is first in deep learning section. In the deep learning area, I use deep neural network. In traditional machine learning, I use support vector machine, neural network, k-nearest neighbor, and random forest. In this model training, I use two scenarios. But in training, I balancing the class. But in A scenario, I do training without standardization data and feature selection. But in B scenario, I train the data with standardization data and feature selection. So we curious about the result of this scenario we choose. Let's see the evaluation. So that we can know in A scenario, random forest have the highest accuracy and F1 score. But in B scenario, neural network in traditional machine learning have the highest accuracy and highest F1 score. But overall, the highest accuracy and F1 score in B scenario training. So the conclusion of in this project is that random forest is the best model for A training scenario when we don't use standardization and feature selection. But in B scenario, neural network is the best model when we use standardization and feature selection. But I recommend to use standardization and feature selection instead, not using them. So it's the better way to make the algorithm easy to train and boost the accuracy. So this is the end of my video. Thank you for watching me.